They are literally telling you how to breathe. What if we use acoustics?
It's kind of like almost the eureka moment that we imagine when we think of inventions.
After all these years, I can see that we are close to something really valuable.
Every once in a while, an idea lands with so much clarity that it stops you in your tracks. That's what happened to Dr. Maria Artunduaga, founder and CEO of Samay. Maria's journey had carried her through surgery, global health, and bioengineering before she ever turned her focus to the lung. And when she did, she noticed something striking. For all of our medical progress, we still rely on slow, outdated tech to understand respiratory disease. But for Maria, one day, a single conversation about air trapping in the lungs led to a eureka moment and an insight that became the foundation for her company Samay and the technology that could redefine how respiratory disease is managed. Maria, I'm so excited to talk to you today. Thank you for taking the time to join me on the podcast.
Thank you so much for having me, David.
Yeah. So many stories make up your arc, your life, the things that you are building. I'd love to kick this off by asking you where you think this story begins.
Long time ago, once upon a time. Well, as you have noticed, I have an accent. So I'm from Colombia originally. I'm from a small city. It's called Neiva. And I'm the oldest daughter of two physicians. I'll probably say that everything starts with my family and the way I was raised. So my mom, she's a surgeon just like you. She actually got into in ENT, ear, nose, and throat. And my dad, he's an anesthesiologist. We are mostly women in the family, so very strong, determined, strong-willed women. And yeah, I spent most of my childhood in this city that was, very rural, very calm. I spent most of my days and hours and lives, of life studying. I went to a Catholic school. So at the time, I was very good at, studying in general. And then, one of the things that some people ask me about, the childhood story and what has sort of shaped the way I am. And I think ever since I'm a little girl, I've been always someone who is super curious about how things work and how life in general works and, the phenomena around me. So I was a very good student. I excelled at a lot of things. And I really like arts and social sciences. Probably one of the reasons why I ended up, doing medicine. And I graduated when I was very young. So I was 16 years old when I graduated.
Wow.
And yeah, at the time, I was the best to score. You have the SATs, right, in the US. So in our case, I was one of the top 10 of the entire country. I got a bunch of scholarships and awards. And I honestly didn't know what to do. I sort of wanted to do medicine, but I wasn't very certain if that was the actual, the right decision. And the question that I asked was, what's the most complicated, challenging, intellectually challenging thing that I could probably do being here in Colombia? And the answer was always medicine. So I've always sort of challenged myself to do difficult things. So I guess that's why I do what I do right now with Samay. I ended up studying medicine 6 years. We do I don't know if you know this, but in countries that are not the US or we go straight from high school to medicine. So yeah, I relocated to the capital of Colombia, to Bogota, and I started very young. I was 16 years old, and I spent most of probably the next few years in Bogota, the capital. I also spent my last year of medical school in the US. So that's how everything sort of started, because I remember that we met right during the surgical interview path a few years ago. Well, a long time ago, by the way.
Decades ago.
Right. I don't know how many years ago.
Hard to say.
2011, man. I think that's so. So I spent the last year of my medical school in the US, and I completed rotations at Harvard Med, Mount Sinai, and Baylor College. And that's how I think everything started, this whole, itchiness about leaving Colombia and sort of trying to get to the place that will propel me as a woman scientist, obviously a doctor, but somebody who was extremely curious about, life and especially academia. So yeah, I think that's how everything started. A very curious little girl.
Wow. Well, it seems like a lot of through lines there that are still part of Maria today. And everything that you're working on. It's so interesting thinking about the many things that you've done. So many of your journeys seem connected to people in your family who mean a lot to you.
Yep.
Tell me more about that.
The original decision to relocate to the US was that my little sister, the youngest one in our family, we are four. There's one boy, number three, and then the youngest sister, Angelica. Um, she was born at 26 weeks old. She was a preterm baby back in 1985. At the time, like literally, there were no NICUs in Colombia except one hospital, probably one or two in Bogota, the capital. And my mom, she was living, this city that it's relatively small, 6 hours away from the capital. And, you know, she started with, preterm delivery. So my sister was born when she was around, 26 weeks. She had a lot of issues throughout, like, her hospitalization with my mom. And she had a lot of, like, respiratory failure. She ended up developing cerebral palsy, hypoxia, right? So obviously she was diagnosed, and her whole, cognitive, especially her motor skills development was pretty much delayed for many, many, many years. So as the oldest sister, sibling in the family, I sort of like, watched the entire thing, right? Like the struggle of my parents trying to figure out how to make her, help her adjust to, society, school, etc. Fortunately, herself intellectually, she's fine to the point that she's actually a lawyer right now today, and she works for the Colombian government. But motor skills wise, she's pretty much, very, limited. So what I saw throughout the span of about, I mean, how many years? Probably 10 years until, 16 years. We are apart about 6 years. Was like, her whole struggle with a lot of surgical, operations. Orthopedic operations, probably five of them across. Yeah, obviously her whole body. She was, full of scars and operations, very tough stuff. My parents taking her to the US, even to Cuba to get her, healed, to get better. They tried everything. And then when I was doing, one of my final rotations throughout medical school, I was one of the few people that I was, that I was capable of communicating English with the accent, of course, but communicating. And I helped out a lot of the medical missions in my hometown. And one of the things that I sort of like, realized was that there were a lot of, American doctors coming to town to operate on, cleft lip, palate, kids. But it was surprising to me that not a single Colombian surgeon, plastic surgeon, was sort of like doing this sort of like procedures just because they say, it's not profitable, right? Like it requires extra training. You have to go somewhere else. It's extremely difficult. So everybody in Colombia, plastic surgeons are mainly focusing on like aesthetics. So something clicked with that and the fact that I was spending time in the US. And I met this doctor, and I think you know him, John Mullican, remember? Boston Children's Hospital, super famous guy. And he sort of like inspired me to become a surgeon scientist. That was sort of like the shape of my life back in the day. I was probably 24 when I decided to become a plastic surgeon in the US, which sounded like a crazy idea, right? And I say, I mean, I've seen my sister struggle. I've seen now these little kids struggling in Colombia just because there are not enough surgeons to do the operations. So my goal became, I want to help kids like my sister to get access to the right healthcare, but still, stay in Colombia, right? The whole idea of like, having to rely on international help or like, sort of like charity type of thing, it really upset me. Like I was very upset about that. Like it didn't make sense to me, right? So yeah, I mean, I don't know, for some reason, I always sort of like pick problems that are associated with my family in a way or another. So yeah, that was my first inspiration at the time when I wanted to become a pediatric plastic surgeon. And I ended up, relocating to the US. And I spent 4 years doing generics research at Harvard.
And you shifted gears towards working on COPD as your time in the US went forward.
Yeah.
You're reacting with a lot happened in between. Is that what you're going to say? Or
Yeah, I know. I think you know sorry. Yes. So I started plastic surgery residency. Things didn't work out. It went awfully, by the way. Experienced discrimination firsthand, the whole thing, complained about it, got kicked out literally. My contract didn't get renewed. And then my grandmother died. She died from a COPD exacerbation, again back here in Colombia. And the mixed of this whole frustration with academic medicine, with surgery especially, the fact that the realization of knowing that I wouldn't be able to fulfill this dream that I had about becoming a pediatric plastic surgeon. I don't know. I don't know if it was crazy or what, because that's what my parents say at the time, especially my mom. I just decided to leave medicine for good. I was like, if it's not going to be the thing that I really want to do, I'm going to create a new path for me. And now I get to decide what to do and where. So the life pivot that I did at day 2 or so was, retraining. I originally started with global public health. I did a master's degree at the University of Washington in global public health for 2 years. I started to work in the nonprofit world, et cetera, multilateral organizations. There was, this institute organization that was mainly funded with Gates, but probably because I'm still a surgeon at heart, type A personality, I'm a very good operator and executor, and I don't have patience for anything. I mean, I'm resilient, but at the same time, I like to be a fast executor of stuff. I like to, at the end of the day, I love to say, I accomplished all of these things on my list, and then I'm good to go, or watch TV or whatever, right? So I did that for a couple of years, and then I ended up relocating to the Bay Area, where I'm on. I'm right now. I'm at the moment, and I ended up doing a master's degree in bioengineering. It's called translational medicine. Berkeley and UCSF, they have this combined program, and I spent about a year or two, learning anything about, bioengineering, product development, and regulatory reimbursement, and you name it. How is it possible for people to sort of spin out academic research, create products and services around healthcare. And for this program in particular, I don't know why they were super heavy on medtech. So that's probably the reason why I ended up sort of developing hardware and medical devices. I guess that's why. And at the time, I took a business class at the House School of Business. And there was this exercise with this famous guy, professor, et cetera, a very famous person, Steve Blank, the Lean Launchpad startup cursors. I think you have seen that, right? Stanford has the same thing. So I did this class, bunch of teams, multidisciplinary, either doctors, engineers, PhDs, and obviously the MBAs. And we put together a little team of students. And then the main idea was let's sort of figure out if there's something in respiratory that we could probably do, right? Some sort of solution that we can put together. And then everything started, I don't know, not necessarily.
And you were assigned respiratory or
No, I chose, my grandma, of course. Sorry, I forgot about my grandma. So at the time I was I'm very passionate about things that are related to my family, especially as a Latina. It's it really moves me because I know that if I pick a problem to sort of solve, it needs to be very challenging. I really like solving difficult things. And then my grandmother had died from COPD, and I sort of proposed this to the rest of the team. Look, I feel that there is something off with respiratory. Again, I come from surgery. I have no idea about internal medicine. I just know that she passed, and that as a family of physicians, we were super frustrated about how she was managed. And the usual, blaming the doctors, didn't do the right, their job well, et cetera, et cetera. It's Colombia, right? Of course, Colombia, our healthcare system sucks. It's not the best, whatever. So I just, convinced them, there is this problem with respiratory diseases. There is something that it's off regarding, either monitoring. I don't know. I didn't understand why my grandmother died from an exacerbation. To me, she had COPD, which is an irreversible condition that makes breathing very hard. And most of the patients feel like they are dying every single day, like they are always short of breath, right? She had that. And I watched her develop the whole, disease for many, many years. And I always tell this story about her taking me to mass every day because when she was visiting, oh my goodness, I had to go to mass with her. Going up for a little hill, she would always be super exhausted. Like she would just suffocate about anything and everything. And I didn't understand at the time she had COPD, right? I mean, I was very young. And then, I sort of started to connect the dots, and I finally understood, oh, that's why she was having so much difficulty, why she wouldn't go out, why she wouldn't walk that much, why she was very scared of having us close to her when we were sick, right? Like, little kids with, the flu, whatever. And then, we started doing all of these questions about 100 people go out of a building trying to figure out what's wrong with respiratory diseases, and especially the way how we manage people when they are outside of a hospital. So that was sort of like a main hypothesis. Like, is there something here for us to solve with technology? And that's how everything started.
I have a bunch of questions that I'm really excited to dig in with you about about Sylvie and about the insights that came. But maybe a half step before we even get there, I'm curious about the unmet need. We talk about unmet needs all the time and sort of understanding that core need. And at that stage in your process, you had unfortunately lost your grandmother. You had a lifetime of experience seeing her suffering from the disease. And you mentioned a minute ago that you were thinking about monitoring. What were you thinking at that stage of the problem that you were hoping to solve? Was it physiology? Was it something about doctors not knowing what the patient's condition was when it wasn't in front of them?
Absolutely. Number two. So the main discovery for me was that the technologies that we have up to today are confined to the hospitals, meaning it's a big machine that looks like a phone booth and it costs you $80,000. And it requires obviously the patient to, get transportation and go to the hospital to do this visit, and sitting in, that phone booth for about an hour and a half to do a stress test of the lungs. I don't know if you have ever done spirometry and all things pulmonary
Once
function
at
test.
medical school, and it was exhausting.
Right?
Yeah.
Yes, exactly. I've done it 8 times, and I'm research subject 0. It's super hard. So you are literally sitting down. You have a nose clip right here. You have a tube, right? Like a little arm, and there is a tube, and you have to cover everything with your mouth. And there's a respiratory therapist in front of you, lovely lady, most of them are women. And they are like an orchestra director. They are literally telling you how to breathe, and all of these, there are probably 7 to 11 different exercises, and you have to follow. It requires a lot of motor coordination to sort of breathe the right way at the right pace without, everything through of that tube without blowing it the air out. I mean, it's super complicated. So you are required to even repeat everything up to 5 times if you are needed, because the way how they sort of interpret the lung flow, the volumes, the curves, it's by sort of watching how they look and how obviously the numbers look like. So pretty much subjective. A lot of clinical experience, of course. So it can take a long, long time. And obviously patients just dislike doing it a lot. So what happens is that, it's complicated, it's cumbersome, it's still in the hospitals. So the way how we manage patients is still, when they are outside of hospitals, is by waiting. It's literally clinical diagnosis, meaning we wait for the patients to tell us how they feel. And we tell them, look, these are sort of the symptoms that you're expected to have if you start exacerbating. Exacerbating is sort of the function of the lungs starts declining and you suddenly have more symptoms and you are required to have some sort of new intervention. You are either, maybe steroids, rescue inhalers, there's something new that it needs to happen so that you don't end up in the hospital, right? Like at the ICU for ventilatory support. So it was mainly, I would say a technology gap that it's still very huge and it hasn't been solved. And to me, again, I come from medicine and surgery, especially. I didn't understand why. So I started talking to a lot of like pulmonologists, et cetera, et cetera. One of the things they said was that, look, I mean, Maria, the lung is still an organ that is very difficult to sort of like understand because, first of all, as a system, it's still very complicated and there hasn't been a lot of research in the past century or so. I mean, most of the things that are happening probably within the next 2 decades with like CT imaging, et cetera, et cetera. But it's not as in cardiac, right? Like in cardiac and neuro, you see tons of innovation, a lot of companies, right? Like spinning out technologies, creating new technologies. The cardiologists are excellent and cardiac surgeons at like innovating or creating new tools to help their lives to be, obviously better and easier. But for some reason, respiratory, that is not the case. But more importantly, one of the things they told me was that usually the innovation, the cardiac space has been potentiated from the marriage of two things: a mechanical engineer and usually like a surgeon, right? So, and you know this from the Stanford Biodesign, right? Like the whole, Fogarty, et cetera, et cetera. Apparently, that has accelerated a lot of innovation in cardiac. And they were saying, I mean, the lung, it's hard to understand because either you use CT imaging and you sort of like get the pictures. But again, radiation, you have to come to the hospital, et cetera, et cetera. Or you do this PFT machine test that it's so difficult for patients to complete that it's just like, it has too many problems. And then the other thing they said was like, look, Maria, the other thing that is problematic with respiratory is like the lungs are exposed to the outside world every single minute, every second you're breathing. So there are so many confounding, parameters of any sort. It could be, pollution, the weather, anything. So it's very difficult to sort of like figure out, but it's really happening, disease-wise. And yeah, and so what happened at that moment when I was doing this interview with a pulmonologist was that he was telling me about his research on something called air trapping. Air trapping. So there is more residual volume, more air that is trapped inside of the lungs, especially in patients that have the worst outcomes. Usually the ones that are dying more often. Yeah, tell me.
Just for our audience, when you say air trapping, I immediately have this like sensation of what that means and what the lived experience of trying to breathe with air trapping is. But could you just kind of describe what that feels like when someone's breathing and having air trapping?
Yeah. So what happens is that, so let's go back to like, anatomy and pathophysiology. Well, again, I haven't practiced in a few years, so bear with me. So most of the times what happens with people that have obstructive diseases is that the airways at the level of a small airway disease, right? Like it's a small airway, like the tiny little things, the alveoli, they start to get inflamed, right? And there's a lot of like inflammation, a lot of like liquid, and it's very difficult for the air that gets in to actually get out. So what they start to develop, and there's a lot of like remodeling around the alveoli. So what it is that makes it very difficult for the air that it's inside to actually get out throughout the exhalation, mechanisms. And they start, I'll say, creating little pockets of air, right? Like, the alveoli start to like get bigger, bigger, bigger because there's more air inside. So that's what it starts to happen with most of the patients that are exacerbating more often. So the way how I see it in like very simple terms is like, my lung is not functioning very well, meaning it cannot do the whole, mechanism of getting air in and out. Therefore, the air that gets in stays inside and starts accumulating inside. And, it makes it very difficult to sort of like do everything beyond that, right? So they start to exacerbate, et cetera, et cetera.
Yeah, it always sounds so scary to me to not be able to take a breath in because you haven't been able to fully breathe out that last breath. Thank you for walking through the physiology happening with that.
Thank you. I mean, I guess
So
I did it the right way. I don't know.
you
You can
did,
correct me,
yeah.
man.
No, that was such a beautiful way to think about what's happening at the smaller level. And so you were walking us through this pivotal day where you were talking with the pulmonologist and talking about PFTs, and you were starting to talk about air trapping. I'll let you keep going.
Sure. So what happens is talking about marriages, right? I don't know. I mean, I guess I married the right guy. So at that time, when I was talking to this doctor and he was telling me about the trapping, and he was showing me the pictures on the CT scans and how you would see, these, you know, black holes, right, on the CT screens, it occurred to me that what if we use acoustics or, signals, sound to sort of like send them through the chest and use the principle of acoustic, like resonance, because the resonance meaning if you have a lung that is normal, but then starts suddenly trapping more air, right? Like the physical characteristics of that lung that suddenly change, right? So I just had a deja vu moment to my high school physics class when I was like 15 years old, back in my little city of Neiva, right? And I was like, damn, I mean, we could probably use resonance as a proxy for something. I mean, like even for a diagnostic type of thing. I don't know. I mean, I'm not an engineer, but to me, it was like sort of like the obvious thing to do, right? Like, physics is very fundamental. So I happen to be married to a guy from Colombia also, who happens to be an audio engineer, all things, digital signal processing. He's very, very good at that. And at the time, I mean, he was working for Google at the time. And, he was leading one of the teams for digital signal processing for the Pixel phone, right? And the thing is, like, we've been married for a long, long time, like probably 18 years today. I don't even remember. But at the time, like a long time. And I always remember Ricardo, he's always playing with sound. Like we are in the living room, whatever we are, just like, your situation with your wife, right? Like he's working next to me and he's always making noises with sensors and speakers and microphones, et cetera, et cetera. And I just thought of like, and I called him on the phone. I was like, Ricardo, what if we sort of like, used acoustics, but using speakers and microphones that you find on phones or headphones to sort of like figure out what is going on inside of the lungs. And specifically, I wanted to sort of like capture trapped air. That's it. That was it. That was the beginning of everything. And of course, he was like, well, yes, it makes a lot of sense. And then we just, what I did immediately after, before getting to the car was like, I went to PubMed. Like, was like, this is something that it's so simple. It's so obvious that I thought there has to be at least 10 papers published on this thing, right? Of course. I mean, I'm not a genius, right? Why not? Well, man, I just found one paper published by a German, I think it was a German group. They actually met the the principal investigator, the senior author, back in May at the American Thoracic Society. I was like, I cannot believe that my paper initiated everything. I was like, yeah, thanks to you, Samay was born, because you validated the crazy idea that I had. I mean, like, So what he did was he called it low frequency ultrasound, but the actual frequency ranges that he used were within the audible range, meaning 2 to 20 kilohertz. So things that you can actually like hear too. And what he did was like he used sort of like a probe with sound, and he put it, I think it was at the front, or I think it was the front or something. And he started sending signals through the chest, and there was a receiver on the other end. And he was capable of showing that you could actually diagnose the severity of COPD and even detect air trapping with a high degree of accuracy. I think it was 89 or 91.
Wow.
And I was like, this is it. So I got back home and I told Ricardo, I think we need to do a few experiments on this thing. And that's how everything started. I mean, it was literally us in the living room. Of course, he's the expert, but he taught me a lot of things about engineering and audio, et cetera, et cetera. So actually, the patents are under my name. But it was very exciting. And again, I just got lucky, David. I was married to the guy that happened to be doing all of these, interesting things, augmenting sound with software, but for another different, like for a different purpose, right? Like consumer devices, phones, headphones, anything but medical. And I had a good, strong person, which was obviously my grandmom, and the fact that I'm a physician. So I don't know. It was, luck, serendipity.
I love that. One of my friends uses the expression talking about the surface area of luck, and you had just the right surface area at the right time. You had the interest in the problem, and you were connected with the right kind of expertise. And one thing I love about this story is it's kind of like almost the eureka moment that we imagine when we think of inventions. Yeah, it really happened. It worked out. Um, so this was very quick, as I'm understanding it. That sort of gee, what if moment, to finding the actual proof, to getting home and noodling around about how you might start doing some experiments. Um, Tell me what the first embodiment of something that proved this principle was. Is this something that you were able to piece together with a couple receivers that same night, or what? Yeah, tell me about that.
It took us a couple of months, actually, because Ricardo, he's still actually working full time now for Meta. But at the time, yeah, he was working for Google. So we didn't have a daughter yet. So a lot of like nights, a lot of weekends, buying everything off the shelf, putting it together. I mean, Ricardo is trained as a hardware engineer, electronics engineer, but like, his background is actually that. But the other away from that into like more software stuff because he's very good with coding. So yeah, I think we did everything ourselves. And we had another friend from MIT who, the Colombian mafia, right? Santiago. So he went to the MIT Media Lab, but he actually did his PhD, and Ricardo went to the MIT Media Lab for his master's. That was Colombian industrial designer. He was working with Intel at the time. And we were, a trio of friends from Colombia, in the Bay Area, in my tiny little living room, a dog and a cat, obviously my pets. And we were, drinking, playing with these, tools and sensors, et cetera, et cetera. And then what I did was that I started contacting patients over Facebook. They have all of these like big communities online, especially Facebook groups that are private. And I started sort of like contacting them to get, additional information on like customer discovery, like what do you think of this? How is it like your lives? Would you be, I don't know, comfortable wearing something? At the time, I wanted to do sort of like an undergarment type of thing. And after interviewing 80 patients, they told us, there's no way I'm going to wear anything that feels that it's compressing my chest. I want a patch. So what Sylvie is today, right, as a prototype, right? I can tell you more about this in a few seconds. Yeah, it was originally envisioned as something different. And it was the patients who told us, Maria, if you build something that I can wear for several days in a row and I forget about it, so sort of like, they were describing their journey of their friends with diabetes, right? Like, the Dexcom sensors, continuous glucose monitoring sensors, or in general, or even the arrhythmia patches, Zio patches, et cetera, et cetera. They were like, I'm down for this. I mean, I'll wear it. And I was like, are you sure if it's a patch? What about the adhesive? Are you sure? It was like, yeah. I mean, I'm so concerned about dying every single day. And I'm already making all of these modifications around my lifestyle. I'm really scared of going out and getting exacerbation and die, right? I want my numbers. I want confirmation of if I have a symptom, if I feel different, I need to have something to sort of like prove it or disprove it. And there was a lot of frustration with the doctors as well. And I understand that clearly because, I mean, it's difficult to manage drug disease patients. And as a doctor, have, the bandwidth to, like, take care of everybody. And it's just difficult to, rely on subjective data, right?
Yeah.
So I started to contact all these patients, and I happened to run into one that was living in Tracy, California, about like 2 hours away from Mountain View, where we live. We just decided to start making trips on weekends with him, and there was another one, George. I think he was living nearby as well. And we started visiting patients to their homes, and we were doing a lot of like, the testing, capturing the data, and ourselves, of course, the health controls. But yeah, we captured the data. We started seeing sort of like interesting data, correlation, especially with respiratory rate at the beginning. And at the same time, when we were working on this, I was doing the National ICOR program with the National Science Foundation. So I owe everything to the American government. We've done $3 million in SBIRs, and we actually resubmitted a new one for $4 million. Our phase 2, our fourth resubmission, by the way. It's a long, long, long journey. But yeah, I mean, like we captured data. We saw interesting data, probably like, I don't know, probably 5 subjects or so. But we did the ICOR program. We got a lot of, interviews in, a lot of letters of interest from pharmaceuticals, hospitals, and anything between doctors sort of like, validating the need. Like, yeah, definitely. Respiratory is a problem. Exacerbations with COPD is definitely a problem. We don't know how to solve it. We don't have anything to solve the right way. We still rely on nurses and telemedicine, and remote patient monitoring, but using pulse oximeters, and we already know that doesn't work. So we are spending a lot of money on nurses calling people. So yeah, operationally, it's actually quite expensive. So yeah, that's how everything started, and that's how we got our first grant, 2018, right before the pandemic.
I also am hearing that a lot of I hate to call it best practices, we'll just call it the only practices that were available at this point, were once the symptoms, it sounds like, the telephone, once people already were able to feel a difference. And I have the impression, hearing you talk about this, that your vision is to spot the progression before it's evolved into symptoms. Is that fair?
Yes, but in the long run, meaning starting up a company, yeah, it's challenging, man. I mean, we veered away from that business model right now. The way how we are sort of like pitching Samay for the round that we are actually raising right now is we are going to offer a replacement for a spirometry, meaning the big device that I was talking about, there are different types of devices that could probably do similar things, probably at the, something that's probably smaller can give you fewer parameters, but it's still used, like in primary care settings. So the main issue
Instead
right
of that
now,
$80,000 phone booth, you're replacing the core functionality with something smaller.
at least the main parameters that doctors are interested in knowing, because obviously that phone booth gives you like, I don't know, too many, probably 50 or so parameters that are definitely important to sort of like characterize the patients, to phenotype them functionally, right? But at least for practical terms, there are a few of them that are sort of like required to either make the diagnosis or sort of like monitor people, right? Like FEV1, forced vital capacity, and maybe the trapping biomarker. So the main idea right now is we are going to help practices quadruple their revenue using the same reimbursement codes for a spirometry. And we give them a device that doesn't take 40 minutes to complete the test, just 10, right? 10 to 15. And it doesn't require you to hire a respiratory therapist to do the whole exercise, the whole thing, the interpretation, because it's going to have AI to interpret the data. And the algorithms are actually working fairly well. And then the other thing is, we are trying to sort of like tell you the same parameters without requiring you to blow out forcefully through any tube or anything like that. It's something that you just place on your chest, 6 intercostal space, mid-axillary line. We are sending signals through the chest from the back to the front. We are listening to the resonance, and with the algorithms, we're capable of telling you those big important numbers right there in real time, AI driven mostly. And this could be, used by a medical assistant, right? Like somebody who, could be, be another, seeing another patient or helping the doctor to sort of like, take a, vital signs in another room. So we're trying to sort of like get into the workflow of the respiratory practices and the primary care physicians as well. But especially is a value proposition at the beginning, pretty much driven by the financial outcomes.
That's so smart. I mean, that makes so much sense. And that seems like the best way to really unlock a large pathway forward is to be able to bring value up front, even if it's sort of stepwise to what you're really excited about. I have some more big picture questions, but I'd love to ask you to brag a little bit about this device and what it does so far, and tell me more.
So the device, I mean, it's been a long road, of course. So today we have 16 granted patents. That's probably one of my proudest moments because I never envisioned myself to be, an inventor of any sort. I mean, like, really?
Say that number again. How many
16.
patents?
16.
Wow.
Yeah.
Wow.
16 granted patents. Our first Latin American patent was, we got the notice of allowance a few days ago. It's from Chile. We have, thank you.
Congratulations. Yeah.
We have 2 in China, 2 in Australia, 2 in Japan, 1 in Israel, another in Korea, 5 in the US, and another in Europe. I don't know, man. I started to lose count, which is awesome. So What it is we are repurposing hearing aid technology. So the way how I'm explaining it to says is we sort of like build a headphones for the chest. And what it does is like, I mean, I don't have the adhesives with me, but right now this thing has two adhesives, one at the end and one at the other end. And we are placing this thing on the chest and we are sending broadband signals, literally like sort of like white noise as a stimuli, sending them through the chest from the back to the front. And we capture the resonance on this end. And we have an app and an actual like web portal for research purposes right now, because we are the ones running right now most of our clinical trials now in Colombia. We stand in Florida, by the way. So the first batch for feasibility that we did included 453 patients, including about 120 with COPD, about 80 something with asthma, healthy controls about 140 as well. Many smokers, many pre-COPD, like sort of like obstructive diseases in general. And we wanted to sort of like, validate equivalence, technological equivalence. Can we use acoustic resonance to sort of like understand, figure out numbers that are pulmonary function numbers coming out from this $80,000 machine? So that's what we spent most of our past 2 years. It was difficult, man. I mean, like, it was hard. At the beginning, I had no hope. I was like, I saw the data. It was super noisy. Everything looked red. Oh, and again, I'm not an engineer, but I was very scared. I was like telling the team, and Ricardo, because he's definitely the expert. I mean, he helps me manage the team. I was like, are you sure we can't do anything with this? And I was like, yeah, I've done more difficult things before. So we started sort of like recruiting a lot of consultants and experts on digital signal processing, obviously in electronics and mechanical engineering. And after the span of probably 2 years, we finally able to sort of like, clean up all of that noise and data. We analyze 20 different frequencies. We call them bands, 700 features so far. And I don't know exactly how they do this. Obviously, it's proprietary. But the thing is that we can tell you a lot of things, such as, for example, we can tell you if you have COPD or not. And we sort of like match that out. Our ground truth is either the doctor making the diagnosis, the spirometry machine making the diagnosis. Same thing with our trapping. And we can also classify the severity of our trapping. And we can predict the actual number for spiral capacity and FEV1, which are the two main parameters used for diagnosis as well. So, and our numbers are between 82 to 93%. So, which is not bad, considering that we still, that was a feasibility. It's not a pivotal trial. And we still need to do some tweaking with the whole device. This new design, this is how it looked before, about 2 years ago. Ta-da! And now I call Sylvie, call her oruguita. And it's a Spanish term for, how do you call it? A caterpillar, I think that's the name.
Oh, the caterpillar. Yeah.
Have you watched Encanto?
Yes.
Encanto, right? So one of the songs by Sebastián Yatra. So that's it. Oruguita. The caterpillar. It looks like a caterpillar, right?
It does. Yeah.
Yeah, and this design, so it has a Stanford Biodesign connection, by the way, I'm going to say it right now. So the third hire for element science, right, from Jay Kumar, right? He's the industrial designer that he's helping us make this an actual product. So he's been working with us. His name is Martin Nenger, and he's been working with us since July of this year. He actually came to Colombia in August. He worked with my team. Obviously, a lot of a struggle, English and Spanish. I mean, my team trying to communicate, but everything's working fine. They are doing now everything remotely. And he helped us do this just under 2 months, man. Like, it's amazing. He's so talented. And I wore this for 24 hours 2 days ago. Comfortable. I slept with the thing on with Sylvie. Didn't even notice anything. Yeah, I mean, I'm actually pretty happy as a CEO. It's like, oh my gosh. Finally, after all these years, I can see that we are close to something really valuable. I mean, I'm close to getting this to the patients to have a product that we could eventually launch.
Well, congratulations. That's so exciting. Something I really admire about you, Maria, is you are so self-deprecating and so humble. And you often talk about how, just to paraphrase, that you're not the smartest, but you're the most persistent.
Oh, yeah.
And I would debate the first part of that. What does that look like?
Being stubborn? Oh, my goodness. Ever since I'm a little girl, I've been told as a woman, especially in a country like in Colombia, right? Like in Latin America, I mean, our culture is pretty much, it's misogynist in many ways. And I'm really short. I'm only 5 feet, really tiny. So I remember my mom when I told her, Mom, I want to be part of a basketball team from my school. I was like, you're only 5 feet. I mean, like, oh, no, at the time, I was even shorter, right? I was a little kid. And she was like, how? And I was like, I mean, there is this, how do you call that? The one that's in the middle? The little one that is directing everybody else? The mini CEO?
Oh,
What do you
the
call it?
center, the point guard?
That one, point guard. Yeah, sorry.
Point guard.
I know this word in Spanish, but not in English. And I was telling her, well, I could do that. And again, she was like, but you need to be very agile, right? You need to run more than the others and be extremely athletic, et cetera, et cetera. So it became sort of like a challenge for me, sport-wise, and I became an athlete. I mean, like literally, I had the six packs, the whole thing throughout my entire primary and secondary school. I was practicing every day for at least 2 hours. Every break that I had, I was, shooting and like moving around and, thinking about a strategy. That's probably one of the reasons why I'm also really good at like being a CEO as well. But, it started with my mom at the beginning. Like she telling me, I don't think you're going to be able to make it. I don't know why she did that. She's so mean. So I don't know. Probably she did that to like sort of like, I don't know. That's the way how she does it. So she was always telling me, nah, that's too hard. I don't think you're going to be able to do it. I was like, I'm going to show you that I can. I went at the beginning to sort of like show my mom that I could do it, even though she didn't believe I could. And eventually sort of like it transformed into like, showing a lot of people that anybody can do anything as long as they work really hard. So it's that sort of like my mantra and the way how I'm capable of doing things, right? And I was telling my employees today because I was doing this 360, like the one-on-one meetings with them. And I always tell them, look, work extra hard, work extra hours. It's going to show. And I'm going to, I see that. And I'm going to award you with like, compensation, et cetera, et cetera. And it really shows when you make more effort into anything in life. So yeah, I mean, that's what I do. And whenever, when I get a no or things don't work out because, life is difficult anyway. I always have, either a plan B, C, or D going at the same time. I'm pretty much the way how I operate right now. It's like, having 3-4 different things going at the same time. For example, my investors update that is going to go out in the next few days. It's full of things because I always have a lot of things, happening and like, going on. It's just working hard and being very strategic about, these ways or solutions that you put in place. And again, I live in the Bay Area. Dude. Come on, how it is to be, you went to Stanford for the fellowship, right? I mean, there are people that are extremely, extremely smart. It's like, but, I just work harder. And I always ask for help. That's the other thing. I have no shame whatsoever to sort of like tell people, can you help me figure this out? Or I'd love to learn how you fix this or how you solved it. Could you share that knowledge or even the resources? And believe me, I'll follow through. I don't need you to do it for me or anything, but just open that door for me. Which, as a woman from Latin America with an accent, it has been definitely key because I don't belong to privileged groups, right? Like in the US, I'm an immigrant after all. And I'm not considered to like look like the actual, successful CEO. So with that, I struggle a lot. And I've been sharing these sort of like experiences before, but I'm very vulnerable. And I mean, you have seen these things on LinkedIn as well, with the struggles and, having the ability to open these doors and to ask people to help me. And whenever I share that vulnerability, people sort of like, recognize it, like become more aware of like, these are the struggles that other people from underrepresented groups are sort of like facing every day. It doesn't really cost me anything, just a little time to help them out. So, and I try to pay it forward too. So, for example, now in Colombia, I'm helping a lot of founders, especially in deep tech, to sort of like, this is the way how things work. And this is how you're going to be examined if you go to a VC. And even though like I haven't really raised any money from actual American VCs, but I have a lot of friends and I've done a lot of interviews and like, of course, video calls, etc. And And I'm sharing that knowledge. And I'm pretty much about democratizing everything, access to healthcare, to knowledge, to wisdom, to resources. I just love that about life in general. And I think that's how everything should work.
I love that. Last question. When you think about what you're building, what's your dream?
Oh God, I think 2035, 1 million people impacted with the device, the technology, in any way, either as a diagnostic, monitoring, et cetera, even research. We are actually generating revenue. Hey! So right now we are getting paid by pharmaceutical, and we have a couple of other contracts in the pipeline from strategics that are willing to pay us for exploratory work for licensing deals that they will eventually, get from additional indications in the respiratory tract, right? So obstructive sleep apnea, small airway disease, asthma, et cetera, et cetera. So yeah, I mean, we are trying to build something that impacts a lot of people, something that truly it's a platform, software platform that has a lot of algorithms for diagnostics that helps a lot of people, not only necessarily in the US. I'm obsessed with the global south and low and middle income countries because that's where I come from. And whenever I see a patient here, my goodness, they are really struggling. For example, just in Colombia, we have a crisis in our healthcare system right now. There is no medication, David. There's nothing. Most of these people are truly exacerbating not once or twice a year, 4 times. So there's a lot of work we could do overseas to help a lot of people, especially because 90% of the patients that are overseas are the ones that are dying and driving those statistics up. So yeah, I mean, that's sort of by 2035 is my milestone, my KPI.
I love that. Maria, thank you so much. This has been so special talking to you, and I'm so excited to keep following this journey.
Thank you so much for the invitation.